So good morning and welcome to UC Tech. As the hosting campus, I'm here from Berkeley in collaboration with UCSF. We really hope you're enjoying the conference, and I'm glad to see we have such good attendance this morning. Our presentation focuses on UC Berkeley's journey in establishing a data lake within central IT. So if that's not what you're expecting to hear, that's what we'll be talking about today. So again, I'm Danny Grieve. I'm the Director of Data Solutions in the Central IT unit here at Berkeley within the larger Campus Applications and Data Group. I'm joined today by Mithra Bondi, who's the manager of our data analytics team, and also by Manohar Rana, who is the manager of our data integration and engineering team. We also have one team member who couldn't be with us today. He had a family emergency he needed to deal with, but he's a data scientist and a platform architect within our sister organization, the Research, Teaching, and Learning Group, and his name is Sandeep Jayaprakash. And so we're really grateful for the support and his contributions to our work here. So our presentation is going to be fairly technical. One of the benefits of this conference is that we can dive a little deeper than some of our other conferences we attend. So looking forward to that. We'll go ahead and look at the technical goals and architectural considerations for our data lake. We'll look at how the lake really contributed in very significant ways to the work that we did during COVID. And we are also going to look how it's re-inspiring us as a data provider on campus in future efforts. We have a lot of material to cover, and so we're going to ask that questions be held to the last 10 minutes. And we'll go ahead and take questions both here in the room and hopefully from our audience online. So in terms of the background and genesis for the data lake, we had some strategic motivations for entering the data lake game. We, up to this point, in 2019 or so, we had a very traditional data warehouse, star schema models behind it. And, it serves a lot of functions, but it doesn't serve all the data demands that we're getting from campus. And so we really are looking over time to modernize our infrastructure to support more unstructured data, semi-structured data, larger quantities of data. We also have issues with our current data warehouse of siloization within our environments where it's difficult for folks to combine data across subject areas. And so there really is interest in being able to combine that data a little bit more dynamically. We also are wanting to support more and more streaming events. We've done a lot of this work with our Canvas team here on campus of streaming events from that system. We are looking at other opportunities for streaming data, say things for like Wi-Fi or log data. And so we still are, it's been 3-4 years, but we still, I think, are kind of at the beginning of the possibilities. And I feel like we've really stood up technology that is going to support us and serve us well into the future. Our work grew out of our partnership with the Research, Teaching, and Learning Group here on campus. They actually had started a local data lake of their own. And quickly, it was taking a lot of their team's resources. And so as often happens on campuses, some group will experiment with something and then you see opportunities to bring it to the center. And that certainly was the case here, that we saw the opportunity of really bringing their work to central IT so we could free them up where they could focus really on student success efforts, learning analytics efforts. And I think that's gone really well. And so we were tightly coupled with them. In fact, we had one of their team members join our team for a full year and work directly with us to stand this up. Now, their team was really focused on a tool called BOA, the Berkeley Online Advising Tool. which has both academic advising aspects to it, as well as student success and some learning analytics capabilities. Again, bringing the centralization of that ingestion and the storage and the curation of the data really allows us to serve our partners. We've really set this up in a way that scales, where we can apply it to multiple domains and multiple types of data, and also different sources. I've been in data warehousing for 20 years, and we've always talked about heterogeneity of data and of environments. And this is the first time I've really seen it actually play out in practice. So it's nice to finally see that. And I said, in terms of the BOA work, I just want to acknowledge they're doing super cool work. If you want to ask some of our partners at RTL, a bunch of them are here. They've again stood up a custom application that supports student advising, and then also some native analytics within that tool. And with that, I will hand it off to Manohar.
Thank you, Danny. So here is a brief comparison of a data warehouse and a data lake. So as Danny already mentioned, we are a data warehouse shop, and we mostly dealing with structured data, and it's always a lot of data. We process a lot of data, and ours is a more matured system, and our target audiences are basically the data analyst and BI analyst who consume the reports through business intelligence solutions. But on the other hand, data lake, we needed, there were some gaps which we were trying to fill. So data lake would add additional capabilities to handle semi-structured data as well as unstructured data, and at a very cost-effective manner. And there was very specific needs from data scientists for machine learning and other advanced analytics capabilities, which data lake was going to fulfill. Danny, can you move to the next slide? So some of the architectural considerations that we were thinking at that time was we wanted a broad spectrum of analytics, right from descriptive to prescriptive analytics. And we also wanted to have variety of data, ability to get into all kinds of data, be it in any format, as you see on your right. But to do all that with a great speed and agility. And we did not want to spend a lot of money on having costly servers. We always wanted to just ramp it up or based on our needs. So through serverless architecture. So yeah, that was it. Next slide, please. This is a very high level picture of our architecture. Yeah, so basically what we have is a centralized storage layer on a cloud with which is divided into basically two parts. On the left hand side is an ingestion layer. On the right is a curation layer. So we get data from a variety of sources, let it be in batch mode or in streaming mode, and we get that in a raw format in an ingestion layer. We keep it there, and then we apply some transformations, some business logic, or to change the types of data. If it is a JSON format, we try to flatten it out so that it can be consumed easily by the end users. There is a semantic layer on the top, which holds all the metadata information, which is used for data cataloging, be it data lineage or data governance, or to provide the security. Yeah, with that, I'll hand it over to Mitra.
Thanks, Manohar. So can you move on to the next slide? Yeah. So yeah, at this point, we have decided to move on with the data lake, really build a data lake. So the question was whether to build it on cloud or versus on-prem. We decided cloud for the known cloud advantages, like being serverless and not have to support the infrastructure, and for the other reasons. And then comes who should be our cloud service provider. We chose AWS at that point, mainly because it was a rapidly maturing vendor. But now if you look at the market, there are many other vendors equally competent in the space. Moving on to next. So yeah, so When we started on AWS, there were multiple services out there. So we had to really pick and choose few of them as to, to really enable us to stream the data real time and to be able to stream large amounts of data and disparate types of data. And for that, we used AWS Glue, SQS, some of the services that are used for data processing. And for data storage, we use S3 buckets. It's basically because it's cost efficient and scalable. And for we have a Glue data catalog that helps us really define the schema and the tables, and in fact, the runtime metrics of the data sitting in S3. So basically for security, we are currently using lake formation, and all the data that's sitting in S3 could be queried using Athena. So it can be queried using simple SQL like our regular RDBMS. And with that said, we wanted to enable the architecture in a way that this data could be consumed by our downstream systems like BI tools and other tools that support machine learning and data science. With that, moving on to next. Yeah. So here I'm going to talk about these services, like key services in detail, especially S3. So this is used for storage, and because it's cost efficient and scalable, as I mentioned. But it's also, from security standpoint, it's actually, the data is encrypted at rest and in transit. And when it comes to, we could actually define the access permissions at the bucket level, folder level, and the object level. So it's pretty robust in terms of security. And the storage standpoint, we are storing the data in Parquet file format, which is a columnar file, but we could choose the other formats as well. We have mainly used it for the easy retrieval of the data. And the other thing that needs to be mentioned here is about the storage classes. Like S3 has multiple storage classes, and these storage classes, like any data that's being infrequently used can be moved to a cheaper storage classes, just thus optimizing the cost and everything. So with that said, moving on to again, so AWS Glue. AWS Glue has multiple components to it. So it plays a vital role in data processing, mainly in terms of data transformation and in terms of scheduling, orchestrating our jobs, and also maintaining a centralized data catalog. Moving on to, thanks. Again, there are multiple components in Glue, and the central one, the core one, is Glue data catalog. And other components basically, they leverage data catalog and really perform their functions. With that, Athena. So how do we query the data sitting in S3 buckets? So for this, we are using Athena, and Athena is pretty simple to set up. Just point it to S3 and start querying the data using simple SQL. It is pretty cost effective in terms of, we pay only for the executed queries and only for the data scanned. Here I'm going to talk about the data processing. So data processing in data lake, it allows us the flexibility to process in batch mode and in real time. I'm just going to deep dive about how batch processing works here and how is it different from the data warehousing. If you see the step one, basically it's a Glue job reading the data from any source system and ingesting the data into our S3 bucket. Step two is the crawler scanning the data in S3 bucket and populating the metadata in the catalog. And step 4 and 5 are the similar steps for curated objects, while step 5 and 6 talk about querying the data in using Athena from S3 buckets, but it leverages the Glue data catalog to read the metadata. And again, there's a data consumption layer here. So how is it different from data warehouse? I need to grab some water, sorry. My mouth's getting dry. So for this, so how does it differ from traditional data warehouse? So we have schema on right in the current data warehousing. So where you have to really define the schema before loading the data. While for the data lake, it's schema on read, which means the schema is being read or created after the data has been ingested. So which means there is a flexibility in kind of, accommodating this evolving source system changes and without having to do any code manipulation. So that's one of the key advantages. And the other thing that we considered is the portability. Like if we were to ever move to another platform, how easy or tough it would be. And it's definitely not straightforward. So we try to accommodate using multiple tactics kind of thing, where we, for Glue, we have highly leveraged on PySpark scripting and SQL queries in order to build our data sets, rather than having to use the Glue native transforms. So which kind of, now we have spin up so many services on AWS. It's definitely not seamless, but we anticipate that if we ever have to move it to a different cloud platform, it would definitely reduce the burden by like 50%. And with that said, I hand it over to Danny.
Sorry, that was a misfire. I wasn't rushing you. So as I mentioned, we were really standing the data lake up at the end of 2019, early 2020. And so we were very focused on that point on RTL's data. So of bringing in Canvas data, bringing in student information system data. In fact, we had a related ServiceNow project. But then a little something happened in early 2020 that I'm sure impacted all of you as well. And COVID hit. And we had this environment stood up, and it actually ended up serving us incredibly well during that time period. And the main thing that I mentioned earlier was the ability to bring in all types of different data. And so we were working with data that we'd never worked with before. So actually talking to university health services, to facilities folks, to environment, health and safety folks, and people in culture for data sets from them that we had never accessed before. And the team just showed incredible resilience in order to stand up a bunch of COVID content very quickly. That really gave campus the visibility into the work that was going on in campus. And just as some examples, we had an acclaimed COVID-19 testing dashboard that we stood up very quickly. I'm sure lots of you have similar stories. We actually were able to leverage a bunch of spatial data that we'd never used before to build things like a potential building exposure dashboard where folks could see where COVID outbreaks were occurring. And this was meeting an important OSHA requirement. One of the more complex and challenging things was, compliance. Are people actually complying with all of the policies they need to where they should be on campus? And we certainly did not enter into a police state, but it was nice to be able to, make sure that folks were cleared for all of the things that they had to get done. And so this is an example of on our mobile app, the Campus Access Badge. We had a corresponding thing on our people cards portal, which is HR related information where you as a supervisor could look and make sure that your folks were in compliance if they actually were in fact going to be on campus. The other area that was sort of interesting is there's a professor, Zach Pardos here on campus that does research on instruction. And based on a prompt from the provost, he did go ahead and focused on instructional resilience during this time. And we collaborated again with research, teaching, and learning to provide him the data sets that he needed that we had created in the data lake for him to perform that research. His overall findings did show that students were remarkably resilient during that first year. And we'll provide a link if you want to learn a little bit more about that research. So great work there. And with that, I will hand it back to Manohar for another tech deep dive.
Thank you, Danny. So this is our event streaming platform. We process around 3.5 million messages every day that comes from learning management system. So all those events are published from the vendor source and Amazon SQS, which basically is a messaging queue service. Subscribe to those messages and get into our system. So this is the gateway, and then every event, every message it triggers a Lambda function. Then Lambda function tries to do some validation. It adds some extra information, metadata information to those messages. And based on the parameters that are stored in an event table inside Amazon DynamoDB, the messages that for some reason fails, do not process, they land up in dead letter queue, and it acts more like a backup. So the system keeps on retrying those messages to process unless all of them are successful. But the messages that they are successful, they land up to Kinesis data stream, which is nothing but more like a broker service. So it publish these messages. The AWS Glue is an abstract ETL layer on top of these messages. So every message that is passing through the AWS Glue tries to add additional metadata information, do some transformation. One stream just simply saves all that raw data into a data lake for backup or for any validation purposes. Plus, it also tries to do some transformations and stored in the transient layer to be consumed by the end users. Next slide, please. So data curation, this is how we curate our data. We do that in a very simple way. There is only one script that calls the parameters. The SQL files are passed as parameters to this particular script, which process those objects. So every object will relate to a SQL, and whichever object we want to process, we simply call it through script, through parameters. AWS Glue performs that ETL job using that script and load the data into S3 bucket. Similarly, our ingestion jobs are also very simple. They are more simpler than this. A single script, we just pass the target, the source and target table names. That's it, and the tables then lands in S3 bucket. Next slide, please. We have automated all our deployment through Terraform. So a single Terraform script includes all the information about configuration, which S3 buckets we need to create. And when we are ready to move from lower environments to higher environments, we just run those Terraform scripts, and all our code is then migrated to higher environment. So this is pretty much automated. With that, I'll hand it over to Mitra.
Thanks, Manohar.
Yeah.
So yeah, security. So data security is a paramount concern when we move the data to the cloud. And for this, in our case, we are using the lake formation to help us with the secure the data. So all the fine-grained access permissions, everything can be controlled through lake formation. So the row level and the column level security has been enforced through it. And in this ecosystem, S3 bucket is actually registered with lake formation. So any AWS component, or be it any application or any user interacting with the S3 data, they have to go through the lake formation. So this is how we have enabled the fine-grained access in data lake. With that, yeah, data sharing. So how do any applications access our data? So most of the applications, like our BI tools, our users, they usually use JDBC, ODBC drivers, or Boto3 APIs to connect to the data lake. But we are also using the cross-account role-based authentication for AWS account users. So for any users who have their own AWS accounts, they can simply use their accounts to query the data sitting in our data lake using this authentication. With that said, I hand it back to Danny.
Great, thank you both for those deep dives. I appreciate it. In terms of our recent work, so post-COVID, items that we've been focused on, we certainly are continuing to expand our data sets. And so we just in the last 6 months have really focused on bringing in even more student information system data. We're on the brink of actually bringing some of the UC learning data local for some reporting needs that we have here at Berkeley. We also collaborated with the Information Security Office and our Berkeley IT cloud team. Moving from on-prem to cloud does come with its challenges and is a real shift in terms of being able to monitor these environments. And so thank you to Allison Henry and her group who coupled with us to get Prisma Cloud monitoring in place, where now we have the confidence of the campus that we're doing things properly and we have insight into those environments, which is great. Mithra mentioned that we are also working on row and column level security. So that's been one focus in the last 6 months. Cost predictability. On-prem is very predictable. Cloud, less so. And it's a little mysterious at times. And so understanding our costs and monitoring those costs have been very important to us. I have a little bit more on that later. Also, thank you to Berkeley IT. As a parting gift, Jen Stringer, our former CEO, provided us with some permanent ongoing funding. Some of these efforts we bootstrap, and that's not really sustainable. So it's nice to have that permanent funding. In terms of lessons learned in future work, we've sort of created a problem for ourselves in some ways. We still have our traditional data warehouse. Now we have a parallel data lake. If I had it to do over again, if I was starting from scratch, gosh, it would be great if that was all in an integrated environment. And so we are definitely going to be focused on how to integrate those environments better and probably move to more of a lakehouse architecture with our warehouse hanging off of our data lake in that technology. That's a lot of work and many years' work. In terms of other lessons learned, even though Mithra said AWS was a mature vendor, a lot of these services are nascent and changing. And so it really is a different way of working and having to be adaptable in ways that we didn't have to be with our traditional warehousing tools. I think that's going to drive us to periodically evaluate our architectural considerations and our business needs. But again, this is a dynamic environment that allows for it. So that's great. Security and data sharing. It wasn't as straightforward to set up our security. We were an Oracle shop. All of that technology was really established. And so it really was a learning for the team. One of the huge ones, impact to internal and external teams. My folks that took on this project, again, traditional data warehousing, we'd been working in Informatica, Oracle for years. And it really was a challenge, and I imagine a scary challenge to step up to working in entirely new technologies, having to learn new things while also having a day job. And so, thank you to the team. We've got some other team members here who really, tackled this and took it on. I'd say to balance that out, the team was super jazzed to do this. I mean, they'd been doing sort of the same thing on repeat for about 10 years. And so this was exciting. Usually our excitement had come from working with new data domains. And so it was nice to have new technologies lending to that excitement. Also, I said in terms of monitoring costs, the way we're set up here at Berkeley, we actually have a central payer account and we all hang off of it. And so it's hard to monitor your own costs very clearly. And so the team actually leveraged one of our other tools, Tableau, to create a billing dashboard so we can get some insights or better insights into our costing and sort of patterns we're seeing. I imagine it would also scream if we had something was running amok and we were getting charged a lot. And so we really hope to share this with the broader campus soon and make it available to them. In terms of our next steps, we do have some demands for, right now, pretty much the lake is refreshing every day and is not doing change data capture for history. We have some requirements for that, so we'll be looking at that. Again, we want to continue to expand streaming and add data sources. I've been super impressed with the automation work that the team mentioned, basically having some basic scripts and SQL driving this, and having more automation focus so that we can actually enter into a CI/CD model is great and perfect directionally. The research project I mentioned, we actually extracted the data and provided it to that professor. And so one thing that I really would like to focus on is how do we actually get our campus analysts and data scientists actually to work with this data in place and actually provide them the tools that they can use it in place without having to take it out of these environments. And so I think that really is the future of how do we provide that self-service for analysts who are getting better. We've got a data science program here at Berkeley now that's huge. And so there's going to be just increasing demand and pressure there. The old tools like Cognos and Oracle Business Intelligence are not going to serve their needs going forward. And so we need to expand how we think about it. I think I belabored the interface and integrate with the data warehouse already, so I will pass along that one. And again, thank you to the team. Great presentation, and we will open it up to Q&A on the floor.
Oh, hi. I wondered if you could just kind of roughly quantify the data or data realms you have in the lake now, and then the resources that it's kind of required to bring that about and maintain it.
Yeah, so in terms of the bulk of the data really is the Canvas data at this point. So from the learning management system for students, namely because that's where we've got the event streaming going on. So just the sheer scale is so much bigger. The SIS data we have is expansive in the system, but again, it's sort of human scale. I think enrollments maybe is the piece that maybe creeps a little closer, but still nowhere near the amount of Canvas event data. The COVID stuff we largely have shut down. It's still sitting out there. But again, that's fairly human scale size data. It wasn't really large data sets. And then we've got also ServiceNow data and then the UC Learning data. So the bulk of it is really more on the student side. Am I forgetting any of the data sets?
That's about right, Danny. Yeah.
Okay. And in terms of resources, what type of resources are you thinking in terms of kind of our AWS costs or people that we're dedicating to this? Okay. Yeah. And like I said, it really is, we have multi-purposed our team, and largely because so many folks want to work in this environment. And so we are making it widely available to folks that want to get in there and work. And so I'd say, our team right now is probably 8 to 10 that have some business in the data lake. And that ranges from either business analysts that are writing SQL, data analysts that are writing SQL, and then the folks that are actually managing that environment.
So I'm curious of that 8 to 10. Are those, is pretty much all their effort involved in the data lake, or is that just casual?
No, it varies across the team. We've got probably 2 that are almost fully dedicated to it. The rest have partial dedication. Okay.
Hi, first I want to say great presentation, super interesting. Thank you. Danny, it's been a long time since we've talked specifically about this, and I think the last time it was mostly conceptual. You all have addressed a lot of different aspects about security, and I'm curious how you manage access approvals when you're combining separate data sets that were collected for different purposes. How do you go about figuring out who's approved for the use and reuse of that data?
Yeah. Currently, the number of folks that are accessing this environment directly is very small. And so it's manageable in sort of an ad hoc fashion at this case. We certainly always end up back talking to the registrar if it's, you know, whoever the information proprietor is or information proprietors, if it's crossing areas where they ultimately would need to provide approval. Our data governance committee is actually starting work on an access working group to better define access on campus. And it is these types of use cases that are kind of exceptional use cases. At some point, I imagine we will be part of a actual workflow where it makes sense, where we'd say, oh, that's a data lake case. We'll direct them to the data lake. But in terms of things like the campus access badge, that was actually an API on top of the data lake. And so it's not like somebody was directly accessing it. They were getting following standard channels to get access to the API. And so, you know, it's nice that we can use interfaces and existing channels to do that type of thing. Great. Yeah, Cass.
That question was a segue to my question. The presenters talked about a row level security and or column level security. So since you guys pull a lot of sys data, and so I wonder if you guys can leverage the security that we have in our sys data. And that goes from the user access to some of the access to, for example, I think currently we're working on legal name, for example, that will be kind of regulated. We can see the legal name. So I can see that we can collaborate with you. This is not really a question, but it's kind of like, I think that possibly you guys can pull our security data into your data lake, working with our security team, and then leveraging that. And in terms of column and row level security, as well as access to the transaction, because in our system, not everybody has access to every piece of data. There's a security layer that we use, and then maybe when you implement your security layer at the row level, as well as column level, and maybe some in the transaction level. So
that's great, Kaz. Yeah, I think that applies to a lot of user access considerations. I think the one thing that always breaks it on the analytics side is like, you certainly wouldn't want the chancellor in your system or, executives in your system. They typically don't have that access, but they would need it on the analytics side. And so I think there's some overlap there. And so, yeah, let's definitely talk about security. Should we take some questions from the chat? Are there any coming in?
There's one question from the chat.
Okay.
So do you have any?
Hang on a second. We'll get you the microphone.
Do you have any billing accidents along the way? And when dealing with massive amount of information, does that reflect when there is billing errors, and is there a higher cost?
I don't understand the question very well. So billing accidents, is that what you said?
Yeah, like unanticipated costs on the billings.
Okay. I don't think we've had an event yet where things went off the rails, but I have heard cases, and I think it was probably when we were working in sandboxes at the time, that before we understood exactly what triggered costs, I think we saw some higher than average costs, but I don't think we ever got to a panic point. Was that the one online question? Okay. How are we doing time-wise?
We're good. We got 5 minutes.
Okay.
And there was one more in Q&A.
Okay. Do you want to read that one, Allison?
Yeah.
Yeah, okay, so can you speak a bit more to the Tableau billing dashboard that you created? How effective have you found it, and how it helps you to manage AWS costs?
Okay, Mithra, do you want to take that one?
Yeah, so when it comes to the Tableau, AWS billing dashboard, our idea, it mainly started off that, we were trying to look at the costs, and we had to log into individual AWS accounts like dev, prod, and different accounts. And that's when we thought, okay, how about getting all this data, having it in data lake, and build a dashboard on top of it. In fact, AWS has a central payer account that we could use, and we could, but that means we would get all the accounts for the campus. So before going that, full-fledged, we thought, okay, let's do it for our team, what our accounts are and get the cost for that. And with that vision in mind, we have actually started getting all this data, but the data is kind of incomplete when we are talking about this, in terms of we could only get our year worth of data, not beyond that, because these services are fairly new in our team. We were okay with that. So yeah, that's how we ended up loading all the data, all the billing data for all the accounts into data lake, and then built a dashboard on top of it. And is there a follow-up question for that? Or
How does it help monitoring? Do we monitor?
it's basically a one-stop shop where we are really seeing the billing for all the accounts in one place. What is the AWS cost, right? So we don't have to really go to multiple accounts to see these numbers. That's how.
Yeah, I'd say we also have a model now that we can extract data from AWS to do this type of thing, whether it's billing or other types of resource usage. If the native tools are great, fine. But if either Prisma Cloud or AWS is not meeting the need, we could build it locally if we needed to.
And this is something we built it locally. So
great.
So I had a question. Can you tell us a little bit about how, when you bring on a new data source from a different team who has different owner, and they have maybe some transformations or enrichment they want to do on that data, within the data lake, do you take responsibility within your team to implement that and build the infrastructure and write the code to do those transformations, or do you provide somebody from that team access to the data lake to kind of do that work themselves? We've just been running into this and trying to figure out what's the best approach to kind of handle these kind of transformations that maybe are owned by a different team.
right. Do you want to answer that? Or?
Yeah. I think in the future, it will look a little bit different, because if we really get to a lake house architecture and we actually have our warehouse hanging off of the lake, that level of curation for a warehouse, you really need to be just with the domain folks, actually defining things, defining business rules, getting to the complexity of transformations that we see in Informatica. What we've chosen to do in the lake so far is fairly light curation. And so things like adding descriptions, information that goes together, definitely denormalizing our source systems, but it's more like a staging area. If you're familiar with warehousing, we're sort of prepping the data before you do something final with it for a particular business goal. And so luckily, I've got two team members, Wood and Ross, that actually came from the sys side. And so they intimately know that data. And so we had in-house knowledge just to stand up those objects. If you don't have that in-house knowledge, you almost certainly would need, I don't know, half of their time for many months to get that all stood up. Okay, looks like we're at time. I do have our contact information here if you want to follow up. Certainly we'll also be around at the events and the conference if you want to grab my sleeve and you have any other questions. Thank you for your time. I know you have choices, and it's great to see you all here. Thanks so much.
Thank you.